Hi folks, making this video here is just a follow-up to the previous video I just made about how to analyze a vibrational system. So in the previous video I just did a math analysis of basically a mass on the end of a 1 meter string. You can see that's pretty well 1 meter. And in the purpose of the video it was to try to calculate the frequency of the system oscillating back and forth. Now I already did this via video, but I went ahead and put kind of an overview of it. So you imagine it gets pulled up to some position and released. Okay? There's my theta 1. Your theta 2, when you write these equations, you always want your theta 2 to be kind of generic. You don't want this to be straight down. You don't want to be at an endpoint. You want it to be kind of somewhere in the middle, so that thing is a variable. And again, this stuff's all in the video, but your PE1 term minus MGL cosine theta 1. Your PE2 term can be written minus MGL cosine theta. A2 1 half mv squared. You end up with an equation of motion that looks like this. I'll move that later here in a minute. And again, this is all in the previous video. I'm just kind of overviewing what I did. You end up using small angle approximation to get this equation, theta double dot plus g over L theta equals 0. And again, theta double dot is just shorthand for second derivative theta with respect to time. That's the angular acceleration. The cool thing is that you're only after the frequency. You can choose which term you want, a sine or a cosine. These equations have a general solution that looks like, a sine bt plus c cosine bt. That's one way to write the general equation or general solution for equations like this. If all you want is the frequency, you can choose the sine or the cosine. In the video, I went ahead and chose the sine. It's all about the value b. That's what I call the angular frequency in radians per second. Sub in, solve it, put out the numbers, just like I did in the video. I calculated the frequency at 0.5 hertz. So what we're going to do here in the video is kind of confirm or see how well the math works against actual frequency. I have a stopwatch at 0. I'm going to go ahead and set this thing in motion, start the watch. I'm going to let this oscillate 10 cycles here and then calculate the time. So, small angle, so start. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And hopefully you can see that in the video there. Pretty well exactly 20 seconds. A little bit short, but again, I did this kind of by hand. I don't know, best seen from there. I'll get kind of a close-up there. Pretty darn close to 20 seconds spot on, 10 oscillations. If you calculate the frequency just from number of oscillations per unit time, pretty well you get 0.5 out of it. So anyway, I just wanted to demonstrate just the power of this method. It's a very powerful method for determining the frequency of a vibration system. And again, it's a relatively simple method. The problems can get complex, but the math is reasonably simple. Write an energy equation, hit with the time derivative. This left-hand side will be 0 if there's nothing adding energy or taking energy away from the system, right? If there's damping involved, you have to take that into account. A lot of times with damping, Newton's second law might be a better way to write the equation. You can still work energy if you correctly do the derivative terms. Remember, damping would take energy away from the system, or perhaps there's some force driving the system. That would give you a non-zero term. But in Physics 221, in all these examples, this will be 0 in entry physics class. You end up with a harmonic solution. For rotational problems, you typically have to use small angle approximation, things like sine theta is approximately theta. And if there were a cosine theta term there, small angle approximation for that would be cosine theta, we would set to 1 for small angle approximations. Harmonic solution, if all you want is the frequency, pick a sine or a cosine, depending on which function you like the best. Sine is an odd function, and I'm an odd person, so I tend to like to use the sine function, and you're after that, the b, that's the angular frequency. Once you have that, sketch a graph, find the period, 1 over the period is your frequency. So, hope that this video helps. Have a great day.